Now that we know about ReLU and Leaky ReLU, let us see how we can incorporate these activation functions at the end of the neurons of the hidden layers using PyTorch in Python. Remember, we wrote this code for a regression neural network to predict pecan yield. Here is the class we wrote. The class name was neural network. We had two hidden layers, FC1 and FC2. FC3 was our output layer. In the forward method, we fed the input x to FC1, then we captured the output of FC1 and we fed it to FC2. We captured the output of FC2 and then fed it to our output layer FC3. Then we returned the output of the output layer from the forward method. There was no activation function anywhere. Now we will include the ReLU activation function at the end of FC1 and also at the end of FC2. That is, the ReLU activation function will be applied only to the neurons of the hidden layers. Remember from the video on the theory of ReLU and Leaky ReLU that these two activation functions are appropriate for hidden layers. So we are applying these activation functions to the hidden layers. We have torch imported. ReLU can be used directly from the torch module as torch.relu. So now I am in the forward method. So I captured the output of the first hidden layer FC1. So the output is X now. So I say torch.relu and I pass the output of the first hidden layer and then I capture the output of this ReLU function. Then I am sending this output of the ReLU function to the second hidden layer. I am capturing the raw logit of the second hidden layer, which I will be sending to torch.relu. I am capturing that again in a variable x. I am sending the output of the ReLU function to the output layer. The output of the output layer is then returned from the forward method. Notice here that the output layer does not go through any activation function. That is because the output is directly the pecan yield prediction. Hence, we do not want to feed the output layer to any activation function. We run the entire code. The neural network now has ReLU activation after the hidden layers. What if we want Leaky ReLU instead of this plain ReLU? Yes, we can do that too. Leaky ReLU is placed under module torch.nn.functional. So we write import torch.nn.functional as f. Then we can use f.leaky ReLU. f.leaky_ReLU. So we are replacing torch.relu by Leaky ReLU. But that is not sufficient. There is one additional item. Remember, Leaky ReLU needs an alpha value for the negative slope. To set that here, we have a hyperparameter called negative slope. We set it to 0.01. That is it. Now the logits of the neurons of the hidden layers pass through Leaky ReLU, running the entire code again. Many machine learning engineers use ReLU for the hidden layers without much analysis. Many directly use Leaky ReLU. For the pecan production data, either or neither is fine. But for many complex datasets, the choice of the activation function in the hidden layers can make a big difference. I will provide the link to this updated code with ReLU and Leaky ReLU in the description section. Thank you for watching. See you soon in another video.